I think so many students see software as such a low barrier to entry with such a high success rate, especially when you consider like software developer salaries
Mm-hmm.
in Silicon Valley and some
Yeah.
other areas of the
Mm-hmm.
country. Why? Of course, people are going to gravitate to that, obviously.
Totally.
So
Right.
why can't we have the same approach with hardware design? The two should come together. You should be teaching hardware design along with coding. You should be teaching all of that stuff.
Hi, everyone. It's Judy Warner. Welcome back to the OnTrack podcast. Thanks so much for joining us today. Today, we have a friend of the podcast, someone you've met before, who is Zach Peterson, the owner of Northwest Engineering Solutions. Zach is also now a technical consultant for Altium, and he's got a dynamic new educational series out that I'm going to share with you. But we're also going to talk about the state of education for both university students, for high school students, and also going into the industry and how we can fill those gaps together. So lean in, enjoy. I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Well, hi, Zach. Good to see you again, my friend.
Thank you very much for having me. It's always a pleasure.
Well, Altium's a large enough organization that I just happened to stumble across some great videos you've made for us. And I was delighted to see you doing video content for us in addition to the blog content that you write for us. So before we really dig into the sort of the education space altogether, can you give our listeners just a quick insight about who you are, what your background is, and just a little blurb about your new video series?
Yeah, so I run an engineering services firm, obviously working with Altium, some other publications in the electronics industry, and then we do a bit of mil aero design and some other unique designs with power products and data center. I came into PCB design and the industry kind of through the back door, working as a marketing consultant and technical writer, and then just kind of diving in head first to design because I enjoy it so much. My background is actually coming from academia. So I started my career really while doing my PhD research at Portland State University. And that's where I started teaching. And that's where I started doing, publishing, conferences, all of that kind of fun stuff. I did my first circuit board while I was a master's student. Didn't really touch it after that for a while because I was doing so much with optics and semiconductors. And then after leaving PSU, came over into the industry, kind of looking for a home, and PCB industry welcomed me with open arms. So I'm really happy to be doing what I'm doing.
Well, I think it's interesting to note that your PhD is in physics, right?
Yeah. So I did my research in random lasers, which is this totally esoteric physics topic. I know. That's the reaction I usually get is kind of a chuckle and a smile. But it's interesting because it's one of those topics where it really is heavily into systems design, especially when you're doing measurements. Some of these measurements are really sensitive, and so you have to have an electro-optical system that can get to these really sensitive levels, and that takes a systems-based approach. Then it's also really heavy on fundamental theory, and so when I was doing my applied physics degree, I kind of had to have one foot in basic science, another foot in engineering, and then another foot in mathematics. So most of my papers on this topic in random lasers are actually math papers. They're not really heavy experimental papers. So I kind of had to do all of it, and having that background in electromagnetics and optics really actually prepared me to do stuff like RF design and high speed design, and I didn't even know it.
Yeah. I always say the things we end up doing in this industry we don't usually do on purpose.
Yeah.
We end up on one road and end up on an entirely different one, but there's lots of directions to go. Well, as I said early on, I ran across your video educational series, and I notice it's getting a lot of traffic and a lot of engagement. So you must be resonating. You've been writing for us for a while, blogs, which have been really well received. But give us a little, I'll put the link for our listeners in the show notes, but I wanted, before we jump into the topic of education, I wanted to give you a chance to do a little commercial for your videos, Zach.
Sure. So the videos are being published on the Altium YouTube channel. So head on over to YouTube, go subscribe, go hit the like button, help us hack the YouTube algorithm, as we like to say when you're a YouTuber, because apparently I'm a YouTuber now.
Yes, yes, you are. Welcome, my friend.
And yeah, so we're doing topics that we know are important for knowledge transfer. We're kind of starting with some of the basics, like what is an LDO? What's a low dropout regulator? What is PCB silkscreen? What do you put in your PCB silkscreen? And a lot of this stuff that I think is not really talked about very much, and it's kind of some of that stuff that you have to either find out by reading online for probably for years in some cases, or you have to pay a lot of money to go and do something like an IPC course, maybe some other industry course, or you have to do like like a course through like a design software course, so through a private provider. You might find it in some educational institutions, but it's really not very common. So there's a lot of this knowledge transfer going from one generation to the next, and to help new designers come up to speed, that has to happen. And this is all part of that. The blogs are part of that too, but this video series is really part of that as well. And so as we keep going, we want to get into some more relevant and advanced topics. Again, we'll kind of ease into that, but there's so
Yeah.
much ground to cover on just the basics.
Yeah, absolutely. And I like that they're sort of in bite-sized chunks too, right? So you're not trying to attack the whole idea of systems design and, all at once. They're nice bite-sized pieces with some good takeaways. So people are really appreciating them. I saw a lot of comments in there. Okay, well, back to our original, obviously you're providing education there to professional design engineers, but you and I share this interest in common, which is about university as well as high school students. And you coming from academia, I think you noticed some things early on when you were at Portland. And so tell us a little bit about, looking back, the things you were observing, the knowledge gaps you saw, where EEs may have been focusing on one thing and then in the real world, it wasn't quite the same. What was, tell us about that, what you observed and what kind of careers, what was coming out of university we're driving to and so forth.
Yeah, it's actually really interesting. So just for context, Portland State University, being here in the Northwest, we're actually really close to a very large Intel campus. And that is actually really instructive as to why I think some of the, I saw some of the things I saw when I was at university. There were a lot of people who were there who wanted to go into the semiconductor industry. So my most of my students were engineers. They were not physicists. The vast majority were engineers. And then of those engineers, the vast majority of them, probably 80 or 90%, were electrical and computer engineers. And so they all had this idea that they're going to go work at Intel. They want to put on the bunny suit, and they want to do that for the next 30 years. Most of them didn't make it past 18 months, but they wanted to go work at Intel for the next 30 years. And then I think there was this other subset that like wanted to start the next Facebook and, be the next Zuckerberg or something.
Right.
Yeah, and there was really much less focus on things like components. There was much less of a focus on things like circuit boards. And there was even a perception that circuit boards are just kind of an overblown way to wire up computer chips and resistors. And like I said, I did my first circuit board as a master's student, but it wasn't really very elaborate. I mean, it was
Right.
just a couple amplifiers, a pin header, some RC circuits for filtering, and then a couple of through holes just to connect back to my power source. So it really wasn't that elaborate. So that circuit boards exist in all this stuff, cell phones, computers, all this stuff you interact with.
Right.
But I think it's so silent and in the background, you really don't
Yeah.
see what goes into it and how complex it can really get.
Yeah. I totally agree with you. And because my background is in PCB, either in EMS or bare board, I wrote a blog once called RESPECT, the PCB, because I think PCBs don't get much respect. It's like the bread you make the really good sandwich on, but it's not the star of the show. But people don't really realize how challenging they are. But to your point, it's not really often taught in university, or you get to do a capstone project like you probably did. And then it's like, bye, have a nice career at Intel or whatever. And then they end up in the real world and it's like, oh, lay out a complex circuit board. And you're like, oh, shoot.
Yeah, my first encounter with a PCB, it's kind of embarrassing to think about now doing, what I do. I mean, we have 6 boards in fab right now. And back then, only 13 years ago, I would have never thought that I was doing what I do now, going into a graduate program. And if it weren't for being required just for making something compact, if it weren't for being required to create this little circuit board to, house an amplifier and a bunch of little circuits, I would have never voluntarily gone that direction, or even that thought wouldn't have even entered my mind that that was something that I would need to possibly do as a physicist, let alone as an engineer.
So, because of my role here and having had some touch on behalf of Altium universities, I've really gotten immersed in this issue. And I've done a little bit of homework myself, but I want to ask you, why do you think that happens? Why don't you think PCB design is one of the mainstays of a ECE education track or curricula?
I think there's a number of reasons. I think part of it has to do with research and research focus being on things that are not necessarily focused just on like on materials or assembly or any of these other things that are actually really important, but they're not part of academic research. It's usually something around that. And
Right.
maybe it relies in some way on a PCB, but maybe there's something off the shelf you can buy, or you just farm it out, or it's kind of an afterthought. So it's understandable. There's
Yeah.
research dollars that are driving attention, and so that's where people focus. Uh, I think another thing in terms of where the student demand is, semiconductors are sexy, so
Totally. I know you're laughing at using that term, but I've used the same term. Like, semiconductors are way sexier than a bare board. It's like rah rah. So I totally get your association. I have said the same thing. So tell me what you mean about that. Like, it's just cooler to design a
I think
semiconductor
there's
right
this
than a circuit board.
Well, I think there's this prestige that comes with being able to fabricate something that's so small with feature sizes down to several nanometers or smaller. And, the wafer just looks so cool, and you're using these huge instruments. And, if you're like in metrology, which I had to do a little bit of metrology for my research, if you're in metrology, you're using these huge microscopes. And I mean, it's all so grand.
Yeah.
And it's hard to make that connection, I think, when looking at circuit boards. So there is that. I think also there's a lot of focus on the challenges in the semiconductor industry, and so people who like to solve problems and who are attracted to solving technical problems, they say, oh, getting over the next hump of Moore's law, I want to do that. I want to participate in
Right.
this because it's this
Right.
huge challenge.
Yeah.
So of course their attention gets drawn there. So those are understandable, and I think just from the students, because of that, there's going to be higher enrollment in these semiconductor design or kind of typical digital electronics curricula. And so I think the curricula as a result has kind of created this vicious cycle where it's catering to that, but it still focuses on the typical like digital design, maybe a bit of analog design. I actually had a client who joked with me that the only reason we did anything with RF design was so that we could pass our qualifying exams, and and after that they just forgot it, you know.
Yeah, that's funny.
Yeah,
Well, I
yeah,
remember Rick Hartley saying something to me once along those lines. Like, I was in one of his classes, I think it was at an IPC conference, and he said, how many people in the room, are electrical engineers that may do circuit design, but they also do PCB design? And there was a handful of them, say 8 of them in a room of 30 or something like that. And he said, which one's harder? And they all said, board design, way harder. And I was like, what? And so I think that kind of like bust a bubble for me. And then Rick also wanted to be a circuit designer. He had that training, was able to do it. But over time, once he entered that space, he found board design more challenging, and he had enough clout with L3 or wherever he was at the time to say, I want to do board design. So,
yeah. I,
and it's Rick
I
Hartley,
yeah,
so,
I never would have cued into that because I mean my mind was always set on, small stuff but really unique and challenging, and you know it circuits didn't seem challenging, especially when you lay them out, just because I didn't really know or understand to the fullest extent what really went into it. I was focused more on like nano devices, fabrication procedures, stuff like this,
right,
especially with metal
right.
oxide semiconductors. It's this totally other thing.
Yeah.
Yeah.
Which I can say nothing about because I don't know that. We are way smarter than me, Zach. So, when did you start to sort of become aware? Like, once you stopped teaching or once you left university, what was your kind of awakening to the fact that, oh, gee, circuit board design is actually kind of important? And what were your observations as far as you mentioned something to me about the demographic of who had the PCB design expertise in the industry once you left academia?
Sure, sure. So, I'll start with the first point. So, I think the light bulb really turned on when I was hired by a law firm. They're an intellectual property law firm to help with and act as a witness. I don't know why they chose me, but they did. So to help them understand how a certain sensor worked. I think it's because it wasn't totally circuit board focused. That's, they wanted someone who understood sensors, and, having done work and published in sensors, I think it made
Right.
sense. But that's when once I started looking at how they interfaced with the devices that this certain case centered around, then it's like it started to hit me. Oh, there's all this stuff that goes into the circuit board that allows you to read out everything from this sensor with low noise and very high fidelity and very fast sampling rate, and ensure that you actually get something that's accurate. And that's when it started to click in my head, especially once you consider where this particular device was deployed inside the human body. So
Oh,
there were
goodness. Okay.
all these other engineering considerations that went along with it, and it was like the dots started to really connect. Yeah, so
Yeah.
that's when the light bulb turned on for me. And shortly after that, I started to get more work in electronics, and then it spanned into technical writing, and it just kind of grew from there. And then after working with Altium directly, like the rest is history.
Yeah. So, what did you notice demographically where you're like, oh, I want to learn more about designing complex printed circuit boards? What was your observation as you sort of entered into this
Y-
space?
My observation was that everyone was older than me.
I know. Well, I
I
I
don't mean I
say
don't
you,
mean that I don't mean that in a bad way, because I respect the experience. It's
yeah,
just
no,
something.
well, those of us that have been around a while, I include myself in that, we talk about there being a graying, literally graying of PCB design expertise. There is, because whatever, we've talked about it before. It's back in the day, you would learn it not in school. It was never taught in school, but you would start as a drafter, and then that drafter became a board designer, and da da da. Now the boards are complex enough that it usually takes an electrical engineer to go into that space. But the ones that know all those principles are older. There's the gap, right? Which is what we're sort of talking about today, is you're not getting it in university. And then the older people in the industry that really do have the knowledge, I mean, a lot of them are teaching, like people that Zach and I know, like Rick Hartley and Eric Bogatin, and people that you see at Altium Live. But they're going to retire before long, right? And they have a desire to give away their knowledge as fast as they can. But there's this gap. And I really love that you're sort of stepping in. You've onboarded as much of that as you can, and then doing things like the videos and the blogs, and I'm like, oh, thank goodness. And so you talked earlier about sort of having this perspective of like a systems-based thinking, less than just one part of the overall of the design. You mentioned that you had sort of this sensibility about you because of your background. And that is another issue we've all talked about before, is sort of the siloing of all these expertise. So can you talk a little bit about sort of the importance of systems-based thinking?
Yeah, well, I think the corollary to that is that you can't just have the throw it over the wall attitude.
Yeah.
Yeah, and I think one of the Altium guys, Vincent Mazur,
Yeah,
he was
Vince Mazer. Yeah.
Mazer. He was the first person I heard say that, and I thought to myself, wow, I totally understand exactly what you mean. You can't have the throw it over the wall attitude. I mean,
Yeah.
I have designers that work for me on projects, but I still have to take an active role in making sure that everything at the system level is going to make sense. And yeah, they're focused on, day one, it's placement. Day two, it's a little bit of routing. Day three, it's more placement, however it works out. But you still have to take that holistic approach and look at everything and have that 30,000 foot view. And a lot of that is just because modern designers have to wear multiple hats.
Yeah, absolutely.
The folks that work for me and that have worked for me for the longest time, they are able to do firmware. They're able to do schematics. They're able to do simulations to an extent. I mean, we're not going crazy with full wave 3D simulations, but
Right.
not on everything. But they're able to do SPICE for some verification. They're able to do placement and layout. They're able to do a little bit of MCAD, and you all got to kind of work together. People have their
Yeah.
strengths, and you don't have to be an expert in everything, but you at least need to be able to play in someone else's pond.
Or at least know what the question is so you could go source it,
Yeah,
right?
exactly. Yeah.
And
I
go ahead, Zach.
I was gonna say I'm not the best coder. Like I can do the block diagrams, I can do the logic. I'm not a polyglot programmer, so I have to rely on other people. But it's exactly like you said. Like I have to be able to say, okay, here's the error in the code. Here's what's wrong with the logic. Here's how this needs to change, and we work together and figure it out. And even if someone
Right.
else is writing it, I still have to understand all of it.
Right. At
Yeah.
least conceptually.
Yeah,
Otherwise, you don't
exactly.
even know where to go get the information, right? And have to be able to. I say this to people all the time, Zach. So I love kind of riffing with you about this. Is I always say, actually, one really impactful presentation I heard was from a guy who was like the VP of engineering at this conference that was speaking to universities. And he was saying, here are the attributes of a student that I want to hire. And it had like their core studies, but all around that it was like a little bit of firmware, a little bit of mechanical, a little bit of, and it was like you didn't have to be an expert at all of those things, but they wanted you to at least touch it and understand it enough to that you could understand how these things were related. And then also soft skills, right? How to work as a team and all this stuff. Because he said, if you come out of university with the bachelor's in EE and that's it, then you're ramped to productivity for Northrop Grumman in this case is way longer than if you were on a student team or you'd done an internship or something and you got to touch all those pieces, grow some of those skills, and you didn't have to be an expert, but you at least needed to know a little bit about each thing, right? And then, yeah, so you are saying exactly what this head of engineering said. I think, like I said, was for Northrop Grumman. And we talk about that. I mean, Altium 365 here, right, is getting a collaboration to happen in the cloud, kind of like Google Docs or Git, right, where you can work cross-functionally in a digital space. So I think that's really interesting, and you're seeing the rise of that as well. So something here we've tossed around at Altium, and you're very much part of, now that you're on contract with us as a technical consultant, is we've thought about, okay, we've succeeded to this point, and we talk about, okay, if we're going to be user-centric, truly, and by virtue of the success we've enjoyed, we feel a little compelled to provide the education rather than just the tool. Like, here's a car, but you don't have a driver's license, So what do you think? I mean, that's the way Altium thinks about it. As you look at the sort of landscape of the industry, what do you think the industries, and we know universities, we wish they would give more PCB design. What do you think industry's role is in getting the sort of next gen design engineers up to speed?
Yeah, so industry's role is, I don't think it's too complex. It's really communicating what your pain points are, just like you said with the VP from Northrop Grumman. Like, this is what I expect. What he's really saying is, this is what I'm missing and would like to see more of. Mm-hmm. So flip that around on its head and look at it like that. There's actually someone who, as part of the Altium Education program that I've been working with from NASA, and we wanted him to actually put together like his list of 5 or 10 things that he wished every board designer knew before coming to work at NASA. And we want to hit stuff like that. And so if you're doing design software, if you're doing, let's say you're doing oscilloscopes, you're doing vector network analyzers, some piece of hardware, and you want to train that next level or that next group of engineers, everybody's got to come together. So there's got to be not just the design software company, not just Tektronix or whoever else is going to be doing the equipment. They all got to come together and present a unified front, if you will, with educational content and material that's going to be compelling for the next generation of designers. And they could be board designers, they could be test engineers, they could be SI engineers, really anything, but they're all going to have to learn to play together. And so industry's role is to really kind of form these teams, I think. And by forming teams and, forming these alliances and having this content that all complements itself, that's a good way to come into the university space, offer these resources, and try and present them in a way that is compelling. Because if it's not going to be enjoyable for the students, they're not going to want to jump in. And I think that directly confronts the issue with semiconductors. And this isn't to say that semiconductors shouldn't be attracting students or anything like that. I'm not up on my high horse or anything, but
right. No, we need those people.
Yeah, of course. We got to have something to put on the boards, right? They have a really compelling product.
Right.
Chips are cool, and let's face it. Boards, we got to make boards cool too. And I think by coming together where it's not just the board, but it's the simulation software, that's going to attract one group. I think embedded and teaching programming alongside hardware design is critical, because so many students see software as such a low barrier to entry with such a high success rate, especially when you consider like software developer salaries in Silicon Valley and some other areas of the country. Of course, people are going to gravitate to that, obviously.
Totally.
So why can't we have the same approach with hardware design? Because they really do go together. I mean, so many systems have some level of computing power.
Absolutely.
Yeah, so the two should come together. You should be teaching hardware design along with coding. You should be teaching all of that stuff. And I mean, listen, the person that takes the hardware design, maybe they don't need to have, maybe they don't need to know how to lay out this, board with this huge FPGA, but they should at least know, like, here's what goes on the board. Here's what this stuff means in the data sheet. Here's how it's going to act when it's on the board. Here's what the engineer who's actually working with the hardware expects from you. Things like this. And so I think those are all fair points to consider when, as groups of industry players come together to create this content for the next generation of designers.
Well, something I hadn't thought about is how we de-silo education, right? Which is kind of what you're saying is if we teach these things sort of in context, right? And don't look like the same silos we're complaining about, we have to be careful not to create those silos in education either, right? And kind of show where the bridge points are. And I think that's a really good idea. I know, and this is not a shameless pitch, but I know you're working on something because I work here, but that you're working on something that is a partner education. And you can come back and talk about that later when we get closer. But I didn't really fully understand why you were doing that, but it makes a lot more sense to me. So like you said, if you're laying out a board, then to do embedded would be a great idea. Or mechanical or. I mean, there's so many pieces of the puzzle. So I think that's a really compelling idea. Okay, well, I know another part of education you have been part of. By the way, for our listeners, I'm sure I've mentioned it before, but I am really excited about it. Zach, by the way, is on our Altium Academy channel, and I'll share the link below where those videos are. That's where a lot of our education content goes. But we're also reaching back to high school students so we get them excited early before they're in college, and then they lock down in a lane, right? And when it's still fun and playful and interesting. So besides now having a full-time education department here, which is great, even though I'm going to miss not being as involved in it as I have been, that we're just doing a lot of things at once. So let's talk about something you've been touching and I know about, but I don't know a lot about it. So I'd like to hear from you about the Upverter education program that some of our internal folks have done a great job building up.
Yeah, so it was a pleasure to participate in that. So basically, the Altium Education program is confronting some of these challenges from multiple levels. So you mentioned at the high school level, and that's where Upverter fits in. Then there's at the college level, which I'm participating in, and then we have plans to go up to the upper level in undergraduate education and possibly into the graduate level. And a lot of that is going to be with partners, and so we're taking that de-siloed approach, and that's what's really important. And I think the Nexar business unit, bringing in those partners and engaging them is going to be really critical to enabling all of that. Yeah.
You betcha.
Yeah, so the Upverter program, being geared towards high school students, it's really meant to be, easy and fun and not this high stress, not tons of math or high stress.
Yeah.
It's more like solving puzzles, and it's less like, cranking through a bunch of calculations like a physics
Right.
class. If you like doing that, go take a physics class. You'll get all the electronics education you need. Trust me. But some of the projects are like just real simple projects like counters, basic robotics concepts. I think those are great ways to hook in high school students. And ideally, they can get to a point where they're going to be prepared to take a more serious electronics design class that is beyond just the typical digital logic type of coursework. That's a lot of what I saw when I was doing my undergrad. It was digital logic. You did a whole bunch of that. You got up to EPROMs and that was it. and you didn't learn anything about like USB. Like, how does USB work? Like, I didn't know that until, I started doing, PCB design. But of course, back then as a student, like, you kind of wonder, like, how does this memory stick work? And you don't learn any of that. And so
Right.
ideally by giving students some of the core concepts around board design and how chips work, and like, I mean, simple stuff like, how do you read a data sheet? Like, the idea is to help prepare them for that. There's also the modular course, and the modular course is really fun because this is more conceptual. Where do you put stuff on the board? How do you figure out like how to move power around the board? How do you select a regulator? These are all things that you shouldn't get to the point where you're on your first job and you're sitting there Googling it or looking on forums to find out the answer, because
Right.
they have really simple answers, but
Yeah,
sometimes the simplest stuff is so hard to find online because you get drowned out with all this other noise.
you bet.
Yeah. So the modular course is really fun because at the end of it, students get to design literally a computer. Literally, that's what they get to design in the course. And I think that's really compelling. And by giving students the right tools, them being able to do that, we're hoping that the light bulb clicks and it's like, wow, I can really do this.
Yeah,
That I didn't realize that it could be this easy.
right. Well, I've said for years that I thought we should reach back to high school because the problem is before university they need exposure. They have to get exposure to it to know it's their thing and they love it, right? And that happens way better with making a little computer or some blinky light thing and go, this is really cool, right?
Yeah.
And it
It's
you
the,
got
oh
it.
my gosh, it works moment.
Yes, the oh my gosh, it works. This is so fun. I want to do it again. And if you're not compelled by it, it's not your lane, but at least you have to give that experience, right? And so that's why I love what you and people on our Upfurter education team. By the way, I'm going to put a link in the show notes because there is a design competition going on. We're working with Arduino and I think IPC Education Foundation, if I'm not mistaken, but it's running now. So there's a fun design contest that Upfurter Education's offering, and I'll make sure I'll put that below if you want to share it with a friend or a kid or someone you know. It'd be fun to participate in that. So you mentioned the Nexar business unit, which for our listeners is our sort of our ecosystem based part of our business where we want to put things like simulation tools right inside of Altium 365. So you sort of like an in-app contextual design experience in the cloud. And so the term that's kind of in vogue right now is talking about an ecosystem, right? Like not throwing over the wall, making an ecosystem where everybody can collaborate, not only say through Zoom or sitting next to you in your desk, but also that you can do that across a country, right? And sort of get out of those silos. So when it comes to this ecosystem based education you're talking about, do you have any thoughts? We talked about simulation, and maybe mechanical. Are there any specific pieces you think about when you think about that ecosystem based education, Zach?
Well, I try and think of it in terms of what's really critical in terms of productivity
Mm-hmm.
and what's really critical for lacking capabilities, which
Okay.
some design software applications are addressing, and then what's compelling for students. I think embedded is going to be the most compelling for students. Like this
Okay.
idea that, oh, I can run a web server on this little stick that fits in my pocket. That's so cool. It's
It
little
is
stuff like
cool.
that. Being able to design the hardware and being able to actually, put together the code, put it on the board, and it goes on its own. You don't have to mess with it. I think that's really compelling for students. I think once you get it, there's another class of students which maybe are a little more like me, who just love solving math problems all the time. And so I think they're going to be really compelled by, I think there's elements of embedded, especially when you bring in like AI, but then there's also the simulation topics. Being able to do simulation right in the design software, or really, one click away from the design software,
Right.
is really critical. And I think that actually addresses another knowledge gap beyond just the hardware design, which is the SIPI, EMI, EMC portion
Yeah.
of
Yeah. Yeah.
electronics. That is its own beast that's really critical. And I mean, you have to know about all the hardware and everything, but there's this whole other set of knowledge that's required, which is a lot of math and physics. And so
Right.
having those two things accessible and that play nice together is going to be a real great enabler of knowledge transfer from the guys who've been doing this for the last 2 or 3
Yes.
decades to the new incoming designers
Right.
who are really hungry to learn it.
Yeah. By the way, I
Yeah.
think I'll put this in the show notes too, Zach. I don't know if you've seen it, but Rick Hartley did a bit about grounding strategies. It's been a couple years now, but I happened to dig it out off our standard Altium YouTube channel. It has like 80,000 views on it, and so many people like, this changed my life. So I think I'll throw that. Speaking of old guys teaching the young folks, I think that was a gold mine. So I'm going to, in the spirit of what you just shared, I think I'm going to plug that one in there too.
Yeah, you should.
So,
I've watched that
okay,
video
you
and I
have?
enjoy it.
Okay.
Yeah.
Okay, I'm going to share that too then. So, Zach, you're not only, you've got your hands in so much. I honestly don't think you ever sleep. But as far as Northwest Engineering Solutions, obviously you have engineering solutions, and you're personally doing things. We mentioned
Learning to delegate.
yes, delegate, yes. So I know you're doing the writing in the video series. Is there anything else that you're doing that you think, oh, one thing I know for sure you're doing has to do with signal integrity journals? If you want to talk about that or any other educational resources that you as a company owner are part of to help sort of solve this problem personally.
Sure. So, I mean, one area where I'm involved in, and I've actually done several conferences on, is in transmission line design and signal integrity around transmission line design. And I'm going to speak a bunch of physics jargon here just for a moment, but specifically in the case where you have dispersion over wide bandwidths and you're dealing with looking at accurately calculating impedance from lossless models by accounting for these effects that happen in real design. So with dispersion, with dielectric or roughness at the interface between the dielectric and the copper, and then looking at real parasitics, so like load capacitance, and then bringing these into a model there where you're able to actually calculate accurately over broad bandwidths what the transmission line impedance is, because other signal integrity metrics start from impedance. So if you can get the impedance and get that accurate and get that to be a causal model, you can get all the other metrics to be accurate and causal. So that's my whole spiel on on the research. And then I still do optics problems. I actually was
And you're
presenting it.
publishing on these topics?
Yeah, yeah.
Oh,
So
okay.
I have two that came out in, no, wait. Were they two in IEEE this year? My last IEEE publication was October of last year. That's right. And then this year it was on random lasers. So I did IEEE Rapid this year, and that was kind of cool. First time I had done a defense conference, but they asked me to do it, so I did. And I got to participate in EDICon this year, which was a lot of fun. A lot of great topics, a lot of well-known speakers, including some folks who have been on this podcast.
Yep.
I did EMC Live this year. That was actually all on radar, EMI and radar modules. That was actually really fun because I got to talk about our experience as a company having to, or being asked to clone several times certain radar modules that are reference designs for use in new products. And it's very interesting that so many different companies are focusing on these different radar modules and cloning them into new systems. So that was actually pretty interesting, and we got to talk a lot about what's going on with radar and imaging, and all of it's interrelated to the stuff that I do research on. For Signal Integrity Journal, working with Altium and Ansys on an upcoming campaign for as part of the Nexar initiative, presenting a lot on a simulation-driven workflow. And there's a webinar series coming up that they're going to be announcing, and I get to participate with some very talented people from Ansys on that. So that's going to be a lot of fun. And I believe you had mentioned something about Altium Live this year in that vein as well.
Yep. So
Yeah.
we've been, Zach and I've been talking in preparation for this, and I think I've got him talked into doing a half-day course for us at Altium Live Connect. So stay tuned for more information on that. I don't want to spoil it yet, but and I wasn't sure if we were allowed to talk about the Ansys thing, but I did hear about that, and that will be upcoming. And when those start coming out, with Signal Integrity Journal, we'll have you back, Zach. And
Yeah.
we'll talk more about that as they start rolling out over the next few months, because those are going to be coming out sort of leading up to Altium Live Connect conference in January. So
Yeah. I think that's the ideal timeline.
yeah, I do
Yeah.
too. I'm kind of excited that it ended up working out that way.
Yeah, and we're
Well,
really happy to be working with Signal Integrity Journal on this. They're a great outlet for this type of content.
well, I love the folks. You know, Janine used to work at DesignCon and was well loved and is doing a great job there. And I used to blog for Microwave Journal, so they're under the same Horizon House publishers. So those are all dear people and very smart people, and there I love to see you working with them. It's really fun.
Well,
It's
thank
a
you.
small world, and I'm glad you're writing for them now, Zach. So I will put a link also to Signal Integrity Journal. And Zach, send me anything else you'd like me to point to. But thanks so much for coming on today and talking about all you're doing. And so glad that you're just jumping in and sort of taking on, filling the gaps for next gen engineers. It's been really fabulous to see what you're doing.
Well, thank you. Thank you very much for having me.
Yeah, my pleasure. For our listeners, make sure you check out the show notes. I'm going to load them up for you, and you're going to want to go check out what I'm putting there. Thank you for joining us again this week. As we mentioned, Altium Live Connect's coming up. I'll put a link in for the design content. So just make sure you go over and check out the show notes. There'll be lots there for you. So thanks for joining us again this week. We'll see you next week. Until then, remember, stay healthy, stay safe, and always remember to stay on track.